Hi, good morning, everyone, and thank you for joining. My name is Emeka. I'm a software engineer, and today I'll be discussing testing code quality and reliable software delivery. As a system grows and the complexity of software increases, without proper testing and strategies, quality, it becomes difficult to maintain confidence in the code as we ship. I mean, like when you deploy codes, you're not comfortable because of the changes, the big huge changes coming in your code base. So that's what we're talking about this today. In this session, we'll explore practical testing strategies used by modern engineering teams to build reliable software and prevent regressions as systems evolve. So the agenda for today, by the end of this section, you should have a clear understanding of how testing fits into modern software development. Um, we'll talk about types of tests, when to use them, and how they work together to protect your system. We also discuss practicals and practices like test-driven development and continuous integration pipelines that helps the team maintain good code quality as project grow. And the goal is not just to learn theory, but to gain practical insights you apply in real world projects. So why testing matters? Why testing matters? One of the biggest problems in growing code base is fear of change. When your code start growing, when your team start growing, the fear of change. You want to make change, you don't want to break things. When there are no tests, developers hesitate to modify code because they are unsure what might break. This slow down development and often leads to production bugs. Testing gives developer confidence. When a test suite exists, you can change the code, run the test, and quickly see if anything is broken. And this allows the team to move faster while still maintaining stability. The goal of testing. A common misunderstanding is that testing is only about finding bugs. I don't think so. In reality, testing has several important purposes. Um, Testing verify that software behaves as expected. They also help the document uh, to help document the intended behavior of the system. When someone new joins the project, reading the test can often explain how the system works, and good tests also help guide design decisions by encouraging smaller or more modular code. Yeah. Types of tests. Um, Not all the tests are the same. Different type of tests are serve different purposes. The three most common categories are unit tests, integration test, and end-to-end test. Each operate at different level of the system and have cache different kind of problems. Understanding how to use each type is important for building a balanced testing strategy. Testing pyramid. A common concept in testing strategy is the testing pyramid. At the base of the pyramid are unit tests, uh, which should be the majority because they are faster and easy to run. Above them are integrated tests, which verifies how component interact. At the top are end-to-end tests, which simulates real user interaction with the system. Since end-to-end tests are slower and more complex, teams usually keep fewer of them. Unit testing. Unit tests focus on the smallest piece of logic in an application. This could be like a function, a method, a small module. The goal is to verify that this piece of code works correctly in isolation. Unit tests are usually done in isolation because unit tests don't depend on external system like database or API. They run very quickly. This allows developer to run hundreds or thousands of unit tests frequently during development. Let's just consider some example of unit tests. Imagine a function that calculates the total price of item in a shopping cart. So in this case, a unit test would verify that the function returns the correct total for different inputs. It might test edge cases like when the cart is empty, discount, invalid input. This helps ensure that the core logic behaves correctly under different scenarios. Well, now let's talk about integration testing. Integration tests focus on how different parts of your system work together. For example, a service interacting with a database or an API interacting with authentication logic on the back end. Um, Unlike unit tests, integration tests involve multiple components. They help verify that the interactions between these components behaves as expected. Mm, End-to-end test is a bit different. It's end-to-end test simulates real user behavior across the entire application. The test typically interact with applications through the user interface or public API. For example, a test might simulate a user logging in, um, adding item to the cart. It could simulate completing a checkout process. This test validates that the entire system workflow works correctly from the user's perspective. Well, I have trees of test types. Each of the tests has advantage and disadvantages. Unit tests are extremely fast. They're very fast. It's just small units, maybe testing just functions, and easy to maintain. They are also easy to maintain. Integration tests provide more realistic coverage of the system. End-to-end tests offer the most realistic verification, but tends to be slower and harder to maintain. A healthy test strategy balances all these three types of tests. Test-driven development. What do you understand by test-driven development? Test-driven development is a methodology where the test guides the design of the code. Instead of writing your code first, the developer begins by writing a filling test. And next, they write just enough code to make the test pass. And finally, they refactor the code while keeping the test passing, and the process encourages small incremental improvement and better design. Test-driven development encourages developers to think carefully about how the code should behave before writing the implementation. It often leads to simpler, more modular designs. Um, Because tests are written early, bugs are caught sooner in the development process. Over the time, the approach can significantly reduce the debugging time and improve overall code quality. Writing good test. Good test shares a few important characteristics. Um, they should be easy to understand so that anyone on the team can read them. They should focus on one behavior at a time to make failures easier to diagnose. Tests should also run quickly so that developers can execute them frequently during development. Because when a developer is writing a code, and it's better don't just wait until you finish writing the code. You should run this test once in a while, as frequent as possible. Um, when writing your code, it helps to reassure you that nothing is broken. Bad testing practices. Well, not all tests add value. For example, a test that verifies internal implementation details rather than behavior can break unnecessary code if refactored. A test that relies on external system or unstable environment are also can also become unreliable. Like your test is based on external system, maybe as API, the data returned back. If tests frequently fail for random reasons, developer eventually stop trusting them. A regression, preventing regressions. A regression occurs when previous working feature breaks after new code changes. This is very common in growing code bases. A strong test suite acts as a safety net. Um, when new code introduces a problem, the failing test alerts the developer before the issue reaches production. Code quality and automation. Testing is only part of maintaining code quality. Automation tools also plays a major role. These tools include linters, static analysis tools, formatting tools that enforce code standards automatically. Automating these checks ensures that quality standards are consistently applied across the entire team. Let's talk about continuous integration as regards to test. Continuous integration is a practical, it is the practice of automatically building and testing code whenever changes are introduced. When a developer pushes code to the repository, the CI system runs the suite automatically. If any tests fail, the changes are rejected until the issues are fixed. This prevents broken code from entering the shared code base. CI pipeline example. A typical CI pipeline contains several stages. First, dependencies are installed and the project is built. And next, linters, a static analysis tool, um, runs to execute and execute those check. You also check that the test pass. Then the testing stage, yeah, verify that the test pass or the test pass. So if any of these stages fails, your code will not be allowed to be merged into the code base. You then need to go fix them locally and commit them, push them back to the branch that needs to be merged into the code base. Testing in real projects. In real engineering teams, testing is part of the daily workflow. Developers write tests alongside the feature they implement. As you're building new features, you're writing the code, the test for them. Don't just build new features without new tests. Code reviews often include reviewing this test coverage and test quality. Continuous integration systems automatically enforce these standards to maintain reliability. Practical takeaways. Testing should not be viewed as extra work. So many people see testing as a waste of time. They see them as doing extra work or, just doing unnecessary things. But instead of seeing them as extra work, see them as being a part of building reliable software. Um, by combining unit tests, integration tests, automated pipeline, team can confidently evolve their system without fear of breaking existing functionalities. Yeah, thank you. If you have questions, you can reach out to me and send the question back to me.